Hey everybody, this video we are getting to the heart of quadratic functions. Just to let you guys know, we're going to spend the last week dealing with quadratics. And then when you guys get back for the Martin Luther King break, there's going to be some type of assessment done with the quadratics. We have spent a great deal on it. Now we're ready to move on to deal with the other functions that we got to touch on. And this is going to give you guys who are moving on to Algebra 3 or pre-calculus a good, sturdy foundation. In this lesson, you will need understand the characteristics of the functions, how its transformation affects the characteristics, factoring the greatest common factor, and mental math skills. Alright, guys, what do we know about this function? About quadratic? We know that the domain is going to be what? R, all real numbers, negative infinity to positive infinity. What about the range? 0 to infinity. And the reason why we use a bracket for 0 because it starts at a specific number. The intercepts are through the origin. The inverse is a square root. Now there are some few surprises that we didn't talk too much of, but you're going to know about it today. The function has a maximum and a vertex. And there's one more thing that I didn't dare mention. You want to learn a specific word. 0. That's a specific word that you're going to be knowing. Which is the match word for today. 0. Alright guys, I'm going to play you guys a clip that's going to answer the question about how the transformation affect the characteristic of the quadratic function. So let's see about it. Guys, although this video is a bit quiet, you see me in Desmos playing. So you see me looking. The red is the original function. I'm currently creating the transformation function. Alright, so let's have a look-see. So far it just moved everything. So the domain is all the same, the range is all the same. But as we keep moving around, as I keep showing you how the graph keeps going, we're going to find out it does something different. Again, the blue is the transformation. It changes the intercepts. And of course it changes the x-intercept too, which it just touches but doesn't cross. And this is just letting you guys know that the graphs still keep going and going and going. So basically I answered the question about the domain and range and how K moves the graphs up and down. But in this case, I talked about H, which moved right to left. But in this case, it moved right. And as a result, we moved right. it changes the intercepts, while the other characteristics remain the same. I think we're good here. All right. Describe the transformation as characteristics. Well, if you saw me in the video, you can answer that question for yourself. All right, let's go ahead and talk about it. What two factors give me 45, but those same two factors give me the sum of 14? 9 times 5 is 45, but when I add them together, they give me 14. What two factors of negative 72 give me the sum of negative 1? So I need for you to kind of think about that. So when we say what numbers give me negative 72? But we use them to find a sum that gives you negative 1. That should be negative 9 times 8. That gives you negative 72. But when we add them together, negative 9 plus 8 gives me negative 1. Right? Guys, what is the greatest common factor that we have to deal with? And remember, to do the greatest common factor, let's do 9 and 27 right quick. The other two I'm going to leave for you guys to do. So 1 times 9 gives you 9. 3 times 3 gives you 9. So let's do 27. 1 and 27 and 3 times 9. Well, we realize that the greatest common factor is going to be 9. And the other two you will take care of. All right. Factor this guy. I want you to actually try this one out for your own self. You try this one out. Take 49 and write it down in the exponential form. You will try this one out as well. All right. Standoff form. Now, those who've been rocking with me at the end of the previous semester, you kind of know how I do all this. So if I were you, I would kind of move on. But for those who just started rocking with me, this is how you deal with this kind of form. Because again, with the quadratic, you're going to see it's working in multiple forms. Now, we're going to solve equations, just not now. We're going to get to that later on. All right. So let's go ahead and do this situation. All right. So when you think of factoring, you see this A, B, C. I need for you to think about the C term. So in this case, the C is 6. So 6. Now, let's get to the B term here, which is 5. All right. Now, this is what I'm asking you to do. I'm asking you to tell me what factors are 6 when you multiply together. Gives you 6, of course, but those same two factors, when you add them together, gives you 5. So 1 times 6 and 2 times 3. So those two factors that gives me 6 that will work to give me 5 while I add them is 2 and 3. So that's going to be 5 equals 2 plus 3 because 2 plus 3 is 5. But 2 times 3 is also 6. So once you get that, you just have to write it in factor form, which is x plus 2, x plus 3. All right. From there, we're going to That is called the factor form. This is called the factor form. So I'm telling you to go from standard to factor, and that's how you do it. Something as simplistic as that. You try that one on your own. Also, I want you to try this one too. And that. Now, in factor form, we got to go back to standard form. So from factors to standard, we got to go back that way. And to do that, we have to use our technique called the foiling method. To do the foiling method, all you have to do is simply just use your foiling method. So let me help you out. So let me do this multicolor. I think that's going to help us out a lot. So let's do F. F stands for first. So X times X. X times X. Well, if you use your law of exponents, notice that when you multiply with the same basis, those exponents, which are 1 in this case, you add them together, you get x to the power of 2, or x squared. Alright, so let's do outer. X times a negative 3. That's just negative 3x. Because that's all you can really do with it. So you just combine them as one. Alright. Inner. Two times x equals 2x. And then last. 2 times negative 3. 2 times negative 3 is negative 6. Now, oh, I'm tripping. I was trying to do this guy. Now, there we go. Much better. I was trying to highlight. Now let's put it together. Now, the first term, you just copy it as is because there's nothing else there to do with it. X to the power of 2. The outer and the inner terms, they got things in common. So you can combine them because they have the same exponent. You could add them together. So add the coefficient. They're the 3 and 2. So if I owe you $3, I paid you 2. Do I owe you? Yes. How much do I owe you? 1. And because I owe you, being a negative sign, so that's going to be a negative 1x. Or you could say negative x. It does not matter. And 6 is by itself, negative 6, and that's how you do it. Just like that, y'all. Exactly just like that. All right. Try this out with a person, and you tell me what's good. All right. Now, we got some complexities going on. In the previous example like this, standard form, A was just equal 1. In this case, it is greater than 1. And A is right here. So in this little method, you're going to do my favorite method. And in class, I'm going to show you the complicated method that people will test you on. I prefer not to use that method, but let's try it. So here, you got 3x squared minus 17x plus 10. Now, you're going to go ahead and do the swing method. Now, let's go ahead and swing it around. So what you do, you multiply 3 times 10. So A times C, and you get 30. And then after that, you rewrite the whole thing. So because I used that 3 at the moment, I rewrite it as x squared minus 17x plus 30. Now, just like what we did earlier, what two factors multiplied together gives me 30, but those same two factors gotta give me negative 17. So x minus 15 and x minus 2 are my winning numbers. Because when I multiply negative 15 times negative 2, I get positive 30. And when I add those two numbers together, I get a negative 17. Because if I owe you $15, being negative 15, and then I borrow negative $2 more, being negative 2, I owe you $17. And me using the word owe means negative. We're not quite done yet. Now, you know the 3 that we used in the beginning? Now we're going to use it again, and we're going to write it as a fraction. Your question is, when you divide by 3, do you get a whole number? So 15 divided by 3 is what? You get 5, negative 5. So what if 2 divided by 3? Do you get a number? No, so guess what you're going to do? You're going to swing that 3. And that's why it is called the swing method. 3x minus 2. That is how you factor that. Uh-oh, we got the same situation here. The only difference is we're going to have to figure out how to factor this. Now, look at those numbers. 6, 15, and 9. There's something going on there. Well, believe it or not, 16, 15, and 9 has a greatest common factor of 3. So in this case, you have to do that. So now with that being the case, you got to pull out a 3. So 3, comma 2x squared plus 15x plus 9. Oh, let me fix that. That's not true. So 3 times 2x gives me 6x. 3 times 5x gives me 15. And then 3 times 3 gives me 9. Boy, it's hard to write with your finger. Now, guess what we could do? Now we could use that Swain method that we did beforehand. And that 3 on the outside is not going to melt no more. It's so far that and you're just going to leave it as is. Well, you see what I'm talking about momentarily. So, multiply the 2 and the 3, that gives you 6. And guys, I do apologize about the struggle. I'm doing this with my finger. I know some of you kids like, what's the difference between you and your sloppy handwriting? Alright, so I just said the same question again. What two numbers when you multiply gives you 6, but you add those same numbers gives you 5. And that's going to be x plus 2 and x plus 3. 3 times 2 is 6, but 3 plus 2 is 5. Alright, so from there, that 2 that you started off with, not the 3, leave the 3 alone because you factored it out in the beginning, so you let that be. Divide that by 2 and divide by 2. So when you divide 2 divided by 2, you get 1. But when you divide 3 into 2, you don't get a whole number. So guess what you're going to do with that 2? Swang it. Now, the 3 you had from here, you put that out there. Because when you factor all of this, it's going to give you back this guy right here. You try these problems. Factoring special patterns, special pieces. Now, for those who was rocking with me, this method was called the difference of squares. Here, you see a square here. What is about 25 that we know in relation to a square? 25 is equal to 5 squared. So with that being said, and also that x. So when you got a situation like this, you just write it as x minus 5. And then you take its opposite, x plus 5. Simple just like that. Now, if I forward this out using my first and the outer last, I'm going to get the same answer. So watch me. X times x is x squared plus 5x minus 5x minus 25. Well, those cancel out because 5x minus 5x is 0, so you get x squared minus 25. That's how you deal with a situation like that. You guys try this one out on your own. I help you with this one. You got a lot to do here. So look, we got this guy and this guy here. What do we know about 4? 4 is perfect square of 2, and we know 25 is the square root of perfect square of 5. So, guess what? Just rewrite it. So, 2x minus 5, 2x plus 5. And that's how you deal with a problem like that. Just like that. Your turn. You try. Alright, take yourself a little 2-minute mental break. This is the part where you will talk to me and ask me questions. Time to deal with some zeros. So look, you guys, when I'm saying the term 0, I'm basically saying the answer. But also, when I asked you about the x-intercept, I remember I write this as intercept. When I say about the x-intercept, I'm pretty much saying 0. So 0 is pretty much the x-intercept. But also it's the answer too, when you solve in these equations. So look, let me give you an example. Let me show you what I'm talking about. So you have factored out a quadratic of x plus 1 and x minus 2. Now, if I was to ask you to solve this equation, you do this. You set both to 0. Sorry about that. It's a thundering outside. I know you guys probably hear it. Anyway, so let's solve both of them. Let's solve the positive one first. Well, when we solve it, subtract 1 to both sides. We get x equals negative 1. And then let's do the negative 2. Add 2 to both sides. X equals positive 2. Well, believe it or not, guess what? They right here and right here. The x-intercept. If I was to ask you that, I'm pretty much ask you what's the answer. So this is another way of solving an equation. So if you don't have time to solve these equations by hand, you can use decimals. And then when you get to decimals, just look for the x-intercepts. All right, the x-intercepts talks up all your zeros. All right, and to go further in the zeros, what I'm saying is, of course, you know, Y is 0 on the coordinate, and X is a number. That's another way of saying 0 as well. So all the stuff I was saying, I'm pretty much saying the same thing. 0, intercept, X, 0. All that pretty much saying what's my answer to my equation if I have to graph it. And that's it. You graph it in decimals. It crosses the x-axis, being the x-intercept. It's the 0. And that's all you have to do, y'all. Just that. Alright, guys. Now we're going to talk about solving this. Now, we're going to solve it in two ways. So first, we're going to solve it by hand. So, of course, just like I did since I knew that the common that this has a common factor of 5, I pull the 5 out. And then from there, you guys, I factored it like I would normally. Send both to 0. And that's why I get why I solve for them. Now this one I'm doing right here, this is the Decimals app that I'm using to do the same exact thing except for I just want to just get to the answer, as you kids would call it. Right now, when you're doing decimals, be careful how you put in your functions because it's easy to make mistakes. Okay, I'm trying to fix it. I'm typing it in. It's the same function. So guess what, y'all? Y'all see the same answer? Yes, I do. Mm-hmm. Mm-hmm. -2 and +1. Shablam. Just like that. So guys, that's essentially all you have to do. It's just that. So on your homework, I may be asking you to solve the equation by graphing. And so this is the way to do it. All right, boys and girls. You are going to do this in your groups or whoever you work with. See to it that you are on task and everything else done. Alright, y'all. Any questions, concerns? Of course, you can speak to me as you'll come to me about problems.